Sweet. Okay, welcome everybody to our last March Zero Trust meeting. Small quorum here. We may have some people join us as we go, but we only got 5 of us on. So Dennis, I see you sent me some stuff at the last minute, but thank you for sending that. So I think we'll start with yours. I don't know, Daryl, did you have anything also that we needed to cover so that I make sure Dennis has time for you or
No, I think we're good. I'm just gonna whatever Dennis shares, I'll feed off of until I get. Um,
okay.
I'm sorry, the ontology group has some stuff they're doing where we're reconciling some stuff, so that will probably play into what we're doing in Zero Trust because there's the part of what we're doing. We talked about this last time, but part of what we're doing in Zero Trust that blends across the ontology work group and then the IOB work group is Zero Trust fundamentally requires sensory input from other sources of intelligence of signal data, and that initially we would look at security point solutions or security um, tools or tool sets, right, from individual vendors, and then subsequently look at the IT service systems that those security solutions, again, point solutions or tools, would be targeting to monitor, to apply controls around, right? For whatever prevention, detection, whatever remediation. So that blend is where I'm trying not to contribute too much until I can see a more clear line in my mind between the taxonomy, the IOB indicators, which is happening at the intersection of machine-human process interaction, and then what we're doing in the Zero Trust framework, which is going to be at a macro level, dependent on some of these other things. Because Zero Trust right now, it sounds like the business thinks about it, but cybersecurity sort of views it as a veil, like just the next shiny framework object.
Could be, yeah.
Yeah, but there it could be more in the sense that it's really just an idea. And then if we can make it into something more than just an idea, something that's sustainable as a model, with key principles, right? And then even a taxonomy that bridges the gap between buying behavior and the other frameworks, right? That's where I think we could make this thing more than it is, than the market's making it up. The market seems to be using this as really a talking point for buying behavior, to influence buying
Oh,
behavior.
certainly, yes. So, which is not a surprise.
Right,
That's
yeah,
right.
exactly. But now
Yeah,
maybe we can do a reverse pivot on it and
yeah.
take what they've meant for personal gain and for actual.
No, I'd like to see Zero Trust create a step forward for IT or for organizations to be more secure. I worry about its complexity is my big worry on this stuff. But
Yeah, mine
I
too.
really,
That's been my biggest thing is as we get into the taxonomy or the ontology pieces, it's psychotic.
yeah, yeah.
Some of the linguistic frameworks that we're incorporating, and I studied in philosophy, I studied philology, which basically and other things related to language, philosophy of language, and
Oh,
I
okay.
mean we're getting dangerously close to like Principia of Mathematica kind of stuff that these guys are
Oh,
throwing in there, like really complex, lots of subtables and tables and too much to follow, and we need some more axiomatic nuggets to stick these things into so people have a system to
yeah.
reference that makes sense to them.
Yeah, it's something they get wrap their heads around. Yeah,
Yes,
yeah.
exactly, that they can practically apply. It's like none of us goes to eat dinner and pulls out a 30 utensil multi-tool out of our pocket. Why? Because we actually want to get nourishment in our bodies. Like, well, there's no real difference between doing that in our jobs. We don't want a hyper complex set of tools. We'll never get our work done.
Well, in most of the IT environments, as you and I know, in today's world, they've grabbed about 50 complex tools.
Well, they're making them worse too because they're calling cloud
Yeah.
something. They're making up terms like cloud when that's just coloing resources, and then they're talking about AAS everything, PAS, IaaS, and all that, when all they're
Yeah.
doing is they're creating complexity so that they can partition resources and maximize utilization, right? Just like what happened in the freight industry with just in time. But when they realize, well, different, right? Because our resources are more complex, but in similar in
Yeah,
some
for
ways,
sure.
they're adding complexity, which is adding risk
Yep. Every day.
every day.
Every day. Yeah. Every day.
Yeah, I
All
feel
right.
like
Well,
this.
thanks for
Yeah,
sharing. Yeah.
yeah. Sorry about that. Go ahead.
Hey, no worries. So, Dennis, you want to kick off some of the material you had sent out? I'll send it. I'll post it later. But I think you sent something out we can work off of. So thanks for that again.
Can you see it?
I can see you now.
And is it big enough?
It is for me. How about Patrick? Is that good enough for you?
Yes, sir. Sorry.
No problem. Okay, that's good, Dennis.
All right, this is just an interim update on the first objective work of stuff that I've been doing to try to connect the dots across open source potential contributors to the first chunk of the portfolio. Consistent with the other decks I've been putting out, we're using a public domain dedication as a disclaimer on the front end of this. So anything in the deck is intended to be wide open and unrestricted. Following Creative Commons 1.0. So the core issue behind the scenes that we're trying to get at is that we're trying to get at an implementation of zero trust architecture as defined in SP 800-207, but using, to the extent possible, open source components. And the point is to do an analogous mapping to what's happening in the NCCOE, which is going to result in practice guides that are recommendations to the rest of the world of this is how you do zero trust with existing technological capabilities. And those practice guides are going to refer to how do you do what's right in the middle there, the policy enforcement when you've got subjects that are identified, the resources they need access to, and policy enforcement in the middle, but across almost all of an entire security portfolio. You'll see endpoint stuff there, network stuff there, security analytics stuff, data security and control stuff, all being part of what at least supports and might be referenced in a zero trust policy assertion. Going a little bit further into the definitional deck, that is sort of the authoritative reference for any entity contributing to the federal supply chain and technologies or services and all of the federal supply chain, but also embraced by all of the other regulatory bodies that have been moving hard towards zero trust as part of their supply chain strategies. In this, the subjects refer to all the users, the roles, the non-person entities, service accounts, all the devices they use. That's all about the user, their platform integrity, and their app, what you know about the user, their behavior, and their resources. On the right-hand side, or the enterprise side of things, the applications, the services, the microservices, the containers, everything that's hosted. And right between them is the gateway approaches, the things that say, here I'm going to assert a rule that says these subjects need access to those resources and the criticality level or the workflow they're related to, or the data classification is X, getting them tied to some form of impact risk. But at that policy enforcement point, the entire security portfolio comes to bear. And the way that it simplifies dealing with the various forms of policy expressed in security technologies is by giving all of those tools, the entire security portfolio, one version of the truth about who's trying to get access to what and what is the risk of it going wrong and what to do when you detect that threshold is exceeded in some sense. So creating one version of the truth where today all of these security technologies have a completely different view of what are the assets they're protecting, how they should behave, and what to do when they don't. So the intent is to provide focus by being uniform across all security technologies on the subjects, the objects, and the criticality associated with them, making that policy decoupled from the specific security technologies. That's interesting when you try to do it both at the user side of the fence, at the gateway in the middle, which is where somebody like Zscaler sits and almost all of the SASE folks and that kind of thing. And on the far right, where you have the application, data center, edge, cloud and multi-cloud environments, where service hosting is the focus. All of them are part of any single security policy domain. And it's not clear that you get zero trust policy without having some footprint in all of these. But that adds some complexion to sort of the implementations. One of the first conformant implementations was the Defense Department's version 1 zero trust implementation. And it is a reference architecture that is an opinionated mapping from underlying security capabilities. Here we have the pillars down at the bottom, which are those underlying capabilities: the authentication side of the fence, the device or app security and posture, the network itself and the isolation due to segmentation or proxies or software definedness, the application and its provenance and development context, and any identification of what's been done to curate that thing. But separately is the course data classification and how that anchors to sensitivity, impact of loss, and therefore priority in dealing with it. What this does is set up a framework for thinking about what's the relationship between zero trust underlying platform enablement. Those are often referred to as the ZT pillars. The only document that still refers to them, I believe, is the CISA Zero Trust Maturity Model. It's no longer used inside of any of the definitional documents, but is used as a way to say, what does the platform have to have before I can construct a zero trust reference architecture on top of it, and therefore begin to enable zero trust policy. Zero trust policy is that policy statement that's in terms of subject and the things that you need access to and the criticality, full stop. It should not have other stuff inside of that policy assertion, but should be compiled into what are the policies, therefore, that I ought to have at the policy enforcement points, either in the end user endpoint or on the data center. There is an intervening point, the policy enforcement between the user endpoints and the hosting environments. That is a place where the gateway vendors stand, and that's often termed zero trust network access. With the balance of those in mind, what we've been trying to do in the first objective of the Zero Trust Working Group was to identify for the category 1 stuff, the first set of things that are being addressed, the discovery, the classification, and the compliance of assets. Are there open source offerings that can cover the required scope of things, some of which we've just referred to? And if so, how do they get put together so they can contribute mutually to a zero trust policy sort of evaluation and enforcement kind of capability? Part and parcel of that is essentially making sense of how the tools respectively contribute to what we understand. With this list, I haven't expanded it past anything. So if anybody sent me any updates, I haven't yet seen them on terms of expanding this or restricting this list. In terms of these, the things I've been running into in terms of things we have to pay attention to from a mapping consistency perspective, or really the following things. And it's this list that is the result of the first pass at these objectives. That is identifying what are the things we're going to have to pay attention to from a standardization perspective to get the tools to work together in a way that reduces the friction, that allows automation, that lets us get at sort of effective leveraging of the tool capabilities. The first, of course, is IDs. We have some tools like Nessus, which intrinsically, without the agent part of it, refers to assets in terms of their addresses in an environment. And so being able to get at that says that there's a network asset ID, very often MAC address or IP address, associated with the information that comes back. But there is also other stuff you see here, including OS query and Open Audit and any of the other SCAP founded tools and that sort of thing, where there's a different identifier, and that identifier can be an asset identifier for an endpoint, may be an IP address, but may have multiple, since that asset might be multi-homed. That asset might be behind a NAT. That asset might participate in DHCP. It can get the picture in terms of that not being a very resilient identifier and creating a significant amount of imprecision and ambiguity over time, allowing the need, and in fact, stimulating the need for asset identifiers that are used more broadly at scale. An alternative that has been used by some systems management vendors is a tuple of identifiers, intending to, in certain use cases, be able to leverage some more than others because they're more resilient in certain circumstances or certain situations. Imagine an endpoint where you just replaced the NIC and all of a sudden the MAC address had to change. In those kinds of circumstances, very normal operational perturbation, you can create discontinuities in the life cycle, in the understanding of configuration and the understanding of the role of assets, if this is the only level at which we do things. Dynamics and distribution make it a ton worse. So virtualize these assets and all of a sudden you have multiple per physical set of identifiers. They are dynamic in the ability to move them at the virtual level and decouple them from the underlying physical, requiring additional levels of mapping to make sense of things. But of course, it's also significantly difficult with respect to what happens in containerization. In all these cases, what used to be single dedicated function or primary function assets now have the capability of having a lot more different usages in a different context. And we'll talk a little bit about what that means in terms of the problem in a second. They also have a situation associated with tints. Zero Trust is intending to take information that comes from, for instance, the development pipeline, like what did you intend as a configuration setting? And the runtime pipeline, what am I seeing as a configuration setting? Compare them and use that information to make a policy decision or to inform a policy decision. So the very same attributes might be used in terms of different sort of intentionality with respect to whether or not it is what you're supposed to see, what you expect to see, or what you're actually seeing. And in doing that, they've got to show up in the same policy predicate at the same time. Because of that, being able, and because those expressions, policy predicates, can be relatively complex, the need to be able to disentangle what's the meaning of the thing I'm referring to in terms of a registry entry that is the one that it should be versus the registry entry that is the one I just inspected with an OS query. Being able to tell the difference in a nested complex expression is going to be really important to understanding the effect of policy, and of course doing analysis about compound policy where multiple rules come into bear. There's also a significant challenge that I'm running into right now as I even look at endpoint tools, and there are different ways of representing key configuration assets in the environments. The one that went splat the biggest was, of course, Windows. As I started looking at the registry, I started noticing that different of the tools made a different level of trade-off with respect to where the good enough bar is. If you're familiar with the Windows registry, you realize that it is one very large database of configuration information, and that it has a lot of parameters. The parameters essentially give you a tree if you're looking at it from one perspective. But when you bring to bear the current user and all the other potential users, you get a branching of the tree, a completely different tree for a different user. When you begin to look at it in terms of nationalization, you get strings that have a representation in one nationalization of an asset, change the nationalization, and all of a sudden the collating sequence, the coding representation can get completely misaligned. And that throws a huge curve at some of these tools that use relational databases or single indexes behind the scenes. Because if you had a single index, or if you use a relational database, any single column is going to have a single collating sequence, which means comparisons and sortings and being able to determine equality is going to be wrong for everything but the primary collating sequence, the primary code set that's used to represent the characters that represent the strings that you're paying attention to. Different ones of these, though, if, for instance, you hit a Windows machine and you look at these strings, well, they don't do either of those things. There's no single index and there's no relational database behind the scenes, which means there is no restriction in being able to switch code pages or character set collation across immediately adjacent values in an environment. So you can have different nationalized strings, absolutely adjacent, meaning completely sensical things, as long as you keep them completely independent. The problem, of course, is that, and this is used in malware environments, that when you do things in Unicode represented one way, but interpreted another, there's plenty of place to hide mal stuff. And that represents a big threat. In fact, a threat that's exploitable in some of these tools because of the trade-off that said, I'll jam a registry entry string into a relational database or into a single index store, which creates a real train wreck that's a nowhere near good enough sort of design trade-off. But it's there, and it's there in some of these tools deep enough that you probably couldn't use them across multiple differently nationalized assets in the same enterprise without creating exactly the problem that we're lining up on. These are just things that we'll have to consider in accommodating sort of a mapping that can actually be defended in terms of the doing what you expect it to do for compliance, for discovery, for configuration, limited to what category one is paying attention. Just to make it concrete, an example right off of my laptop is essentially this. You jump into the registry, you go to HKey users, which is what gives you this projection of multiple trees, the entire registry fragments at this point. And for one user, you get a particular set of assets associated with app events and console and control panel and all that other stuff, including environment variables. For another user, you get a completely different set. The ability to parameterize across the users, which can be very idiosyncratic to individual assets, some of them local, some of them enterprise, some of them otherwise. Being able to ask the question, do I have a run key set wrong, can involve you asking the question across all of these users, not a single registry parameter or not a single registry projection in the environment. It's almost always the case against a registry that you wind up doing a query rather than doing an asset attribute test at a particular path for a particular key that's not effective in terms of getting at posture or getting at level of security in those environments. So aligning the query syntax is really important, but each of the tools makes a different trade-off there. And so part of our normalization is going to be, do these folks focus on a particular projection in the tree? And if so, a particular nationalization? And if so, what do we do to do the mapping? It's not going to be just take this string, compare it to that string, and if their regex shows them to be equal, then they are. That's not going to work at all. The primary dimensions that have come up in at least the registry for now have been pivots, the tree fragmenting on user, on nationalization, on the kind of Unicode normalization done in the particular tool, and then of course temporally. The endpoint tools have all sorts of flexibility as to when they sample things like the registry and any other attributes. The network tools have a different perspective on them. The time at which you do the evaluation of configuration settings and the attributes that you use to characterize discovery matters because it can change. And so the ability to get consistency across a time base for tools that are managed completely differently and possibly globally becomes an interesting challenge as well. So getting to either a decision about what we do in terms of normalizing what we do for time basing and how we represent these tools actually go after the APIs. They're not things that just look at the logs. So what you do in the logs can be different and inconsistent with what the tools will tell you when you do actual interaction with the API. All of these issues are normal issues that have been dealt with in the compliance automation community for at least the last decade and a half. But the solutions to these challenges don't seem to have made it into the security tools, which seem to be used in a lot more simplistic set of assumptions in terms of dealing with assets. And there's some interesting challenges. There are standards that solve the problem. The DMTF SIM schema, for instance, in Windows, which is Microsoft's tabula rasa for getting at all of configuration of a Windows environment without orphaning any of these issues, works works just fine, but it is complex, it's large, and it's not embodied in most of these tools. That's sort of where we're at in terms of at least what I've done over since the last meeting, and beginning to get concrete examples of sort of what's going to be the challenge when we try to look across this open source set of tools, each of which has evolved relatively independently and with a different understanding of what it is they're trying to do. They have not acted to make it easy to connect information from their respective points of view into one thing that's going to inform, for instance, a single zero trust policy predicate right in the middle. A few of them are going to be convenient. Open FISMA, Open Audit, Open SCAP, anchor to other standards that have already addressed some of these challenges in ways that allow convention to at least provide some commonality, not always a complete solution under the covers. I think that's it on the status. So it is the getting more concrete about where the alignment challenge is going to be in attempting to get a set of tools that have evolved independently to contribute in a way that is analogous to maybe some of the portfolios that are beginning to emerge from the NCCOE. I think the result is we're going to pick sets for which making the mapping consistent is low-hanging fruit, that it's easy, and that there are some for which there's going to need to be some disambiguation in the tools to be able to actually connect the dots in a way that's going to be consistent and scalable over time. Questions on anything that I talked about?
Excuse me, sir. Where's your AI bot that's actually running right now? I want a copy of that.
It's coming from the scar tissue. Go ahead.
So one of the challenges here is there's like you said, it's very complex, lots of nooks and crannies, a lot of deep rabbit holes, and there's a lot of best of breeds that do very well in one of those particular scenario domains like registries. So some are really good at very specific elements.
Yeah.
Few are good at everything. And so that adds challenges on top of what you've already identified in terms of how do we get homogeneity on whatever thing we're trying to do with just so many different pieces that are in constant motion. So not only is the technology driving the registry complexity constantly changing, so are the tools, and I think we probably should just all retire and sit around and drink good tequila and talk about the good old days.
I tell you, to some extent, engagement with this problem is inspiring me to think more about tequila. So.
No, and it is, and I'm wondering, like in the case of registries, is it possible to approach this with a functional test rather than trying to find some specific thing that's going to enumerate and audit the zeros and ones? There's a way to do some sort of role-based authentication functional testing to validate that the thing is either set or not set as required for compliance with the policy.
So there certainly is. The kink behind the scenes, especially with something like Zero Trust, is the tests, the various parts of the predicate are supposed to be an independent verification that the assumption about integrity, about authentication, about authorization, these are supposed to contribute to your understanding that that is still true for the current access. So we don't want to get too far away from what the data source is really telling us. The efforts that have tried to do, I think what you're alluding to here, include something like XCCDF, which said, you make the control functional at a level that's decoupled from the underlying platform, and for the platform you do that mapping once. And then anybody that needs the control after that doesn't have to worry about the snarly mess that's under the covers. So an example is to set password complexity is different in Linux than it is in Windows. The XCCDF control says set password complexity, whatever you want it to be, whereas the mapping to the underlying OVAL instructions in the SCAP portfolio then is the place where an application platform specific test that says this is how I do that in Windows, that's how I do that in Linux, that you get that amplifying effect of essentially simplifying and making functional the requirement and completely decoupling it from the technical details of how do you do that on this platform. That is worth considering since it's already done and we could leverage it. But it is back in the relatively conventional SCAP platform. I don't think the work has been done, or I haven't seen it in InSpec yet. I know that you don't have to worry about it if you're doing things like DMTF and the SIM schema, but you get the complexity of that schema coming back at you, which for people who've been writing and using some of these tools may cause a nauseous reaction because it dumps you right into all of the complexity of the registry when you use the registry provider and the SIM schema. I think you're right. If we can focus on the controls and have a level of indirection between the control and the underlying platform, we may be able to contain the complexity such that an adapter is the place where it's all confined and it doesn't muddle up everything else. But it is something we have to intentionally do, because it doesn't seem to be done in most of what I'm seeing here. Almost everybody here said, oh, assume everything is US nationalized, assume that the collating sequence is a particular selection that's consistent with the nationalization, and then finally assume that all of the assets are user endpoints and they have one NIC. And when you do that, then lots of things snap into focus, but they can be wrong and can be pretty dramatically wrong, if that makes sense.
Yeah, in terms of effectiveness too. Then we wonder why we're in trouble.
Yeah, every device seems to be a multi-homed router, and so the assumption of a single work address is a bad one.
Yeah. Well, as you said earlier, folks have been trying to come up with some sort of practical approach to this for, well over a decade.
Yeah. So the challenge I'm trying to face here is not, can we come up with a solution to the bigger problem? Simply, can we come up with an acceptable normalization across the tool set here so that we can use this to participate in creating an effective open source representation of how you do what NIST is doing with largely commercial tools. So I'm trying to keep it boxed. But
yeah, it's easy to state. I don't know how we do it. We need an abstraction layer. We need to extract out the complexity.
there you go. Wave it away.
So, Dennis, do you have any suggestions? I mean, I like your idea that it would be nice to normalize across this tool set, and certainly that's something that standardizing disparate tools, which you got to get to somehow. Is there any way, talk about containerizing, is there any way we can kind of define something to get a piece of it modeled and see if we can plug them together and then evolve? Or is there any suggestion on how do we go about it?
Yeah, well, the fastest way forward, I think, is to take that set of things we have on the right, the tools that we're trying to integrate, and sort of collect them into equivalence classes of those that have the most similar way of looking at the stuff that's there. In that case, I can take two things in that equivalence class that have a same, think Nessus, the scanner on the network, and Nessus, the agent augmented capability. There's already a mechanism there for unifying these, and we didn't have to build it. It doesn't answer all questions, but it does everything Nessus can do. And because of that, there may be a way to say, okay, what we're really trying to do is solve those problems that we have listed here, and we don't have to do it for everything with one grand unified theory. Maybe all we have to do is do it in the expedient ways that let us get an endpoint and a network view effectively leverageable from whatever it is that the tools are. So maybe these tools shouldn't be considered as isolated Legos that can be plug and played independently, because then we'd have to solve that bigger problem. But instead, maybe they are coherent subsets of or equivalence classes of stuff that can work together well. And maybe we should just identify that so that we get a network view and an endpoint view, and they work together, even if it means I have to consider some of these in pairs that work well together. So I think that's what I want for the next objective is I'll dig into these for, instead of their differences, where are the similarities? Are they groupable into chunks that can co-leverage things? I know for a fact, for instance, the OpenSCAP stuff can be correlated with the OpenFISMA stuff because they refer to the same underlying standards. And so the stuff that's already been there in OVAL and CPEs and CVEs and all that other stuff that's still there. And it does the job in at least FISMA environments and others. And so we know they can work together and have schema that are made to work to make that happen. That's less true where you have tools that have essentially not paid attention to either the SCAP environments or to the DMTF, the sort of vendor, the guys who write the operating system, their schema for looking at the world, which exists both in the Linux and the Windows side of the fence. Past that, I don't think we want to get in the business of creating yet another one of those grand unified schema. But I do think we want to leverage them, and they may not be with equanimity applicable to all of the tools. Does that make sense? So I'm trying to find the expedient way forward that lets us use the tools, enables sort of the open source participation in contributing to the SCAP or to the Zero Trust sort of potential solution without having to wrangle with this soul absorbing bigger picture problem.
No, I completely agree. And the segmentation, as you're talking about, is the trick, right? How do we slice it in a way that we get our hands around something? That's always the trick in these things. And I like your focus on network and endpoint. That again brings in the world of XDR, right? Which is what that is. So,
well, yeah, that's the intent there. Except that it seems like all the XDR vendors have their own way of cobbling things back together.
Yes. Okay. Yep. No, I agree. That's right.
Now, if you guys are seeing anything that's a promising sort of way forward that sidesteps the nastier issues, I'm certainly interested in it. But this is just intended to communicate what I've been spending time on.
The only thing I haven't done yet, that's what I planned on doing, was looking at the vendors in that XDR space to see how they're collaborating. Because a lot of them are endpoint vendors dreaming of networks, or network vendors dreaming of endpoints. So they got to cross the bridge, and I'd like to see what they did. Because you wouldn't do it if I was either of those vendors. You'd want to do it in some generic way, because I wouldn't want to be like a network vendor like Palo and have to deal with every single endpoint vendor uniquely. That just doesn't make any sense, and vice versa. So they had to do something.
Yeah, and we know a lot about what they did. For the guys who were going at relatively conventional IT infrastructures that are fairly static, think of what Palo Alto did. They added agents to what was previously next generation firewall capability, and then used their assumptions about how dynamic, how distributed the assets were to decide on a correlation mechanism that said, if I've got an agent, it can report to me at least that agent's view of what the IP address is, and that gives me a basis of correlation as long as I'm not on the wrong side of a NAT or a load balancer or something like that.
Certainly. I do know of one I was going to look at, though, which is another vendor called, I don't know if you know these guys, but they're called Exabeam, and they had an XDR alliance put together.
Yeah.
And so I was going to look at just to see how they were doing. They bounced about a year ago, so they probably had enough time to do something. And I'm just curious what they did. I wonder if that'll help us here. Do you think it'll be relevant, or they got extra hop in there? Extra Hop, Mimecast, Netscope, SentinelOne, CyberArk, Recorded Future are all in that.
Well, I'm hoping that the integration schema is in the open, and that's the only risk there, right? We don't want is to dig into and inadvertently step on sort of intellectual property right in the middle of the glue, if that makes sense. But you're absolutely right. All of the analytics vendors that have to pull this stuff together have decided on some way of doing a correlation. But it generally has been one way to do it for conventional architectures, one way to do it for modern architectures, and
that's right.
Sort of the number of permutations. So adaptive techniques.
Yeah. And I'm not sure how their XDR alliance. They talk about XDR alliance separate than the company, so I'm not sure how that's organized in terms of openness, but we could probably look at it.
Yeah, and I'll bet you they expose sort of a correlation mechanism, because they, as a platform, would want to own that and tell the vendors map to this to participate in the ecosystem.
Very, very, very possible. Although if they've got multiple SIM vendors in there, that ain't gonna fly. So so like SentinelOne's in there. I don't think they'd want to map to Exabeam schema. just guessing.
Well, no, that's true. Look at the problems we've had with the standardized log formats, right?
Yes,
Which
that's
was,
right. Yeah, exactly. There's at least 3 standardized log formats. What are you talking about? Yeah.
sorry.
Yeah.
Tickling the scales.
Okay, so maybe I'll look at that. I'll just look at that. I'll see. I thought I was going to do it anyway. I was going to look at that to see what, because as we were talking about, and as you're talking about, there's got to be a way of pulling it together. And they've had this problem just in XDR, as you were mentioning, the network and the endpoint. So so they got to do some kind of modeling or some kind of mapping, I guess, of the environments that they're trying to pull together.
Yeah. Well, if you find something, or if you want me on the call, either way, let me know.
Yeah, I pasted in the chat the link to their website, to the XDR Alliance. So I pasted it in the chat for those that want to look at it. I mean, I was going to look at it, but they do have a alliance pulled together, and that website is hosted, I think, by Exabeam, but it's supposed to be an alliance across those vendors, which are listed at the bottom of that web page. There's 2, 4, 6, 8, 10 of them.
So the interesting market driver behind this is that in the executive order from the White House, there is the requirement on all federal systems to have EDR capability deployed. But what that meant was that the guys who are capable of interpreting the information coming back from NDR, EDR, XDR kinds of tools, there's not a set of those guys in every one of the agencies. So they need to be able to look across instrumentations and telemetry.
Sure.
And so that is a potentially strategic place to scan. If you could get a critical mass of those folks to actually adhere to your schema, it provides a way to have a smaller set of expertise look across a larger set of enterprises, all of whom might have different EDR, MDR, XDR kind of instrumentation.
Right. Okay, just a thought. So I'll take a look at that a little bit. But I sent the link out if anybody else wants to look at it. The XDR Alliance, it's called.
Looking at it now. Got it. Anybody else? Other questions, suggestions? If not, I bounce it back to you, Russ.
Okay, I think Forrest, you had something you want to present. You're more than welcome.
I do. Audio check.
Yep, we got you.
Yep, we got you.
Okay.
Unclear.
So we've been trying desperately to make some progress that people can see. So let me share my screen. Let's see, screen. 2. All right. See my screen here?
We do now, Forrest. Yes.
Yeah, so, I know there's been lots of begging, several cries on the call for us to get progress done. So we're trying to make some progress. So what you see on the screen here is just Ian and I and others, we've been breaking down. So let's go back to this graphic right here. We're trying to develop the ontology use case, which just covers in this, for those of you who've seen this malware detection kind of graphic that we've had put together here. We've taken this use case and we're just trying to model the infection and detection portion thereof. Not all of the rest of this blocking and updating email scanners and all of that stuff. Just the part about he clicks on the wrong link and he gets infected, and his computer runs, I think it runs the antivirus software and actually identifies that something bad's on the computer. Only that portion. Okay, so that's important. So we started out putting together some of the instance level information. So the actual first order logic, the stuff in reality that's a part of this scenario. Of course, it's not really reality, so it's all fictitious reality, but assume there's a person named Bob who really exists. Okay, and so there's a person named Bob and there's a person named Charlie. And so we got a lot of these details from the use case, but there's a lot of details that we would actually need to make this effective that are missing in the use case. And that's just kind of indicative of the difference between what we can absorb in our craniums by just reading a couple of paragraphs and what the computer absolutely cannot absorb by just looking at a paragraph. So, so this is kind of in just kind of narrative, breaking it down, table format. These are things that are involved. We got the Bob, who's the end user, who's an employee of Initech. We've got Charlie, who's a SOC analyst, who actually isn't going to be involved in our use case yet because he rolls in on the updating software and doing SIEM assessment and all that stuff. Then we've got Agent 3, which is an unknown malicious actor, and that's the the indications of behavior folks are actually interested in the behavior of that person who is unknown, so we can model them as effectively as possible without them giving you a copy of their playbook and their intent, right? So it goes on and on here. So then what I asked Ian to do was, Ian, take a stab at graphing this out. So the actual triples in graph format. Now keep in mind, Ian is not a cybersecurity person. So he took a stab at it. This is his stab, and I'm not going to go through this because it's kind of convoluted. But what I did was I took, based on his work, and this is what I've been doing on this call, so I was only half listening in to Dennis and everybody. Sorry about that. So but I took and I started breaking it down into the first component of this. So you have the spear phishing event, the email that was sent, the spear phishing email that was sent, which precedes an infection event, which then precedes a detection event. And then the spear phishing event, I broke it down into two occurrent parts, so two components. So when I say occurrent parts, those are two parts that are not physically existing, they're temporal parts of an event. So you have the act of the email delivery, and then you have the act of opening up the link. Okay, and then the act of the email delivery, Bob hasn't actually sat down his computer yet, so there's assumptions that occur here, and we may not have the data that all relate to this, but they did occur. And so these are the type of gaps in our knowledge that we look to fill in when we're doing the analysis. And now we know where those gaps actually fit logically next to each other. So we do know that Initech has an email server. So the email was sent to the email server, so it showed up there in the email server first. We do know that it went from some malicious computer. We do know that it went from an email account on that malicious computer. We know that there's somebody out there who controls that email account. Whether they have bots doing stuff or not, they're actually somebody out there doing it. So you have this agent 3. So, and I don't have the data level property, like for example, their name, things like that. We haven't mapped that out yet. But we know they have the role of a threat actor, which is realized. So agent 3 participates in the act of email delivery. He has the role, or she has the role of a threat actor, which is realized through this email delivery role. We also know that there's a server that some computer that they operate. They have an email account that they control, which resides on the server. That's all participating in this. And then the computing device kind of receives the email. And then you would have also, and this is, I don't have it articulated, but there would be a where and when should be articulated too. They're also features, if you will, or related to the event, where and when that part happens. And then we do know that precedes the active link opening, and that's basically when Bob, he gets into it now. He's an end user, but he also now has the role of a target. So you know his day-to-day role is end user in all cases. But in this case, he is going to be a target in this, again, realized through this active link opening. He controls an email account on which, in the email account, what is that logically? That's a debate that we had last week. We decided on it's what we'll call a directive information content entity, which is akin to like a contract. It says what he is allowed to do and not to do as relates to emails, for example. And then the email account is part of, or a component of this email software program. And so Bob, he's going to operate on his computing device. He's going to get access to his email program through this email software, which is also going to then participate in this active link opening. So it has a role here also of a target. And then I showed just in this case, this is the only class example I have here of being a target role. I don't have these yellow circles for the rest of it because I just didn't have time today and there's not room on this chart to boot without having to move things all around. But that then tells the computer what all of this stuff logically is. And then these links here tell them what's related, how they're related. And then what else is missing is the data properties. All this thing like, IP addresses, ports, email software types, versions, those to MAC addresses, all those things don't show up on here yet, but they are all logically tied to some of this components on this sheet right here. Hopefully that's helpful. That's where we're going with this use case. And so we're going to put all of these, so you know what classes, what all these are logical classes of, whether it's a person or a computer or whatever. All the data property that's associated with these things, data properties, we'll have them all tied into here. And then we can make, so this is just PowerPoint deep right now, but we would put this in triple format. And so that the computer would then ingest those triples inside the computer, it would understand this graph. And then our next step is to compare that with UCO. So this is going to be modeled in BFO/CCO structure of an ontology, which is different than the UCO structure. And so we're going to compare the two once we get there. And then the TAC piece is going to really drill down on this stuff all over here as well. And so we'll see how Ryan models it out as relates to this and how easy it is to relate the two components. Was that helpful to see where we're going?
It is.
Yes. Yep.
Yes. And of course, this is just so all of this graph, it doesn't even show up on that use case. It's implied in here. So everything that you see here, well, not all of it, 80% of what you see here is implied. Whoops, where are we? Is implied in somewhere in here. But in order for the computer to be able to do the analysis, for us to link the threat detection stuff and the indicators of behavior of what the bad guy's doing to this, we have to get to that level of fidelity. So that's where we're going. And so we're gonna go. So our intent here next couple of weeks, I'm gonna kick this back to Ian, and we're gonna basically do all three of these components get blown out like this with data properties attached to it. And that's what we're gonna run by everybody. And so when we were getting input from everybody last week, it was a lot of the data properties that we needed to put together to each of these things. And so we'll fill those in, run it by everybody again, and then share it with the DC3 crowd.
Is there any intent to look at whether this stuff connects to common attack patterns or the attack matrix MITRE stuff?
Yeah, I mean, what you do is you figure out the data properties that are observable. Data properties means basically, so the indications of compromise, those are, in most cases, those are data properties. So that's pieces of data that give you some indicator of a compromise. And so that puts into here. And so we put those into where they logically fit. Unfortunately, the attack matrix is not logical yet. It's still just kind of like a general binning. So there's still some kind of mapping that needs to be done. But I mean, yeah, the intent is to show, how the components of this use case how you can pull out those components that fit the graph of an attack as defined in the attack matrix, if that's what your question is.
Yeah, I'm just thinking that the ability might be leveraging the bottom-up detection and isolation that MITRE does in the attack matrix or in the KPEC standard. That lets you then populate what's the underlying telemetry that connects to what you're seeing as action.
Well, at a minimum, what we would want is anything that would say, attack in the attack matrix, this type of event or this type of malicious act would have these components. We would want to make sure all those components are somehow reflected in here so that you could create then the graph of that attack. And if it's not in here, then we have to figure out, what is it? What is that component that we'd be seeing that we somehow didn't have articulated into this representation?
Makes sense.
So now, of course, we're only going to, in this use case, we're only going to the detection component of this paragraph, which is where in the verbiage, I don't have it, but it's basically the antivirus runs a scan and it notices that there's software on there that has some malicious signature, and then alerts alerts the SIEM or on the next query from the SIEM, it alerts the SIEM that there's something malicious on their computer. So that's as far as we're going to go for this particular use case, just because that's complex enough. But I think in most cases, the attack matrix is a little bit more complex attacks than just the launch of the spear phishing. But we might be able to find it in there too.
And in it has, for instance, kinds of detection for particular spear phishing campaigns,
Okay.
which would let us just connect the dots one level lower.
Yeah, so I mean, what's missing in here is the actual email message. I just hadn't gotten that far. So there's an email message that shows up. It's going to be participating in the active email delivery, and it also participates in the active link open, because that's what's common across this, is that message that was sent and that Bob then sees and responds to. So that's what's common across these two things, is the actual email message. Ian's got it over here. I just hadn't got a point to malicious actually email message. So the email message that contains a URL which he goes to download the malicious software. So the actual malicious software isn't in the picture yet until the infection step, because that's what you go back to the server to get to download to the computer, right? So
yeah.
What is involved in these first two subsets of the spear phishing event is the actual message. I don't have that on the screen yet. And its structure and its content, those would have indicators that, theoretically you'd be looking for. So I'm getting there, or we're getting there. I'm going to send this then back to Ian and say, use this kind of structure, not this structure. I think it'll be easier to follow.
Yeah, I agree. That's much easier.
That's much easier to follow. Yeah.
Okay, I'll stop sharing. So that's where we're headed.
Okay, thank you, Forrest. Anybody else have anything else to share? Well, because it's 5 o'clock somewhere.
5 o'clock somewhere, including here.
Thanks, guys.
Guys.
Okay, have a good day.
Good day.
Thank you.
Thank you.